All right, you guys, we're doing 3.6. This is the last section in Unit 3. That means we're halfway through AB Calculus. So exciting. Okay, so we're doing antiderivatives. Another word for an antiderivative is an integral. Okay, so we're starting to learn our integrals, which is just basically going backwards. Okay. So first we're going to differentiate each of the following. So differentiate means take the derivative. So the derivative of 3x of x cubed is 3x squared. And then the derivative of x cubed minus 10 is 3x squared. And then if I had a c right here, which would be any number, the derivative of that would be 3x squared. So notice that when I look at this, I have, no matter what my c value was or what my constant was at the end, I still got the same derivative, 3x squared, okay? So when we take the antiderivative or we integrate, we have to keep in mind there could have been a number here that I didn't know what it was. And so I have to take into consideration that number, okay? So if I take the integral of this, I have to think about, I'm doing my derivative backwards, okay? So if this power is a 2 and I'm going backwards for my derivative, I'm actually adding 1 to the power, so that would be x cubed. And then remember that that number goes down in front, so that's where that 3 is probably going to come from. So I have to divide by that 3 because it wasn't there to begin with. That was the power I brought down in front. Okay, so, and then I have to remember to add that c, which I need to know is called the constant of integration. We're always going to have this plus c, okay? We always have plus c. That's why if you ever hear, don't forget your c, this is what it's talking about, that plus c, okay? So another way we can write this is to say the integral of 3x squared dx equals x cubed plus c. Okay, so this just gives you some definitions. When I have this symbol, it's called an integral symbol. That's antiderivative. The expression that you are integrating is called an integrand. The dx just gives you what the term, what with respect to that you're using. It doesn't change your integral at all. And then the c is called the constant of integration. So what we're going to do is we're going to learn some rules for taking integrals. Okay. So first of all, we have the power rule. And the power rule is where I have x to the n. When I take the integral of n, I'm going to increase that power by 1. We're going backwards than when we did the derivative. So remember when we did the derivative, we subtracted 1 from the power. So now we're going to add 1 to the power, but then I have to remember to divide by that same n plus 1 because I have to get rid of, when I took the derivative, I brought the power down in front. So we have to go backwards, okay? So an example of what we did on this one is we had x cubed, okay? And that gave us 3x squared. So we have to think about if I take the derivative of x cubed, I get the 3 in front, and that becomes 3x squared. Okay, but if I'm going backwards, I have to figure out what was it backwards. Okay, so this is like if I have x cubed. Okay, now if I'm going backwards from x cubed, then I'm going to add 1 to the power. That gives me x to the 4. And then I have to divide by that 3 plus 1, which would be 4. So that's all that's saying, that power rule right there, okay? That's the one that you use most often when you're taking the derivative of polynomials. The constant rule just means if I have a number and I take the derivative of just a number, I get that number times x plus c. So if this number was, if I was doing the integral of 2 dx, then this would be 2x plus c. I'm putting an x next to my number. Okay, then we have a couple of rules that go along with integrals. Scalar multiply just means if I have a k in front of a function, I can factor k out and make my number smaller if I want. You don't have to, but you can. Don't ever factor out if there's an x. Okay, you can only do in numbers. The sum rule means I can break apart a polynomial. So if I have like x squared plus 3, I can take the derivative of x squared and I can take the integral of x squared and the integral of 3 separately. Okay, so let's go through some trig rules. So I have to think about, I know that the derivative of sine is cosine. Okay, so the sine x would be my original plus whatever my plus c was. So if I take the derivative of sine, I get a positive cosine. So that works. If I do it this way, I end up with the derivative of cosine is negative sine, and that is negative. So I have to have a negative to begin with so that the negative cancels out. So the derivative of cosine is negative sine, but then the integral of sine is negative cosine. So we have to think about it going forwards and backwards. And that just comes with lots of practice and lots of note cards, flashcards, okay? Backwards for secant squared is tangent. And then secant tangent is the secant. So if I had a secant and I took a derivative, I'd get secant x tangent x, right? Okay, so over here, the backwards for cosecant squared is going to be negative cotangent. And then cosecant cotangent is going to be negative cosecant. Okay, so it's the same ones that we had the negatives on before. Because it was going to be a negative, I have to put another negative to get the positive back. And that's just getting those down, going backwards on those. Okay, so now we have some examples to practice these. So what I want you to do is pause the video. Before you do that, let me help you with a couple of them, okay? So with 3 over x squared, I'm going to write this as 3x to the negative 2. And I'm going to write this as x to the negative 1/2. Okay? With this one, we're going to write it as root x divided by x squared plus 1 divided by x squared. So I'm separating it. Okay, and then I'm going to separate this one so that it has a sine of x twice. Okay, so I've got the sine of x twice, and I'm going to let you go from there. Okay, so let's see how you do on that. Push pause, try to get these derivatives or integrals, and then come back. Don't forget your constant of integration, u plus c. All right, welcome back. Let's see how you did. So here I'm going to get 1/4 x to the 4th plus c, because I add 1 to the 3 and I get 4, and then I divide by 4. Okay, this one's going to just be 2x plus c. This one is going to be t to the 5th divided by 5 plus 2t plus c. Doing good so far? Okay, now we get 2y squared plus 4y plus 1. So this is going to be 2y cubed divided by 3 plus 4y squared divided by 2 plus t plus c, not t, plus y. Got to use the same variable. Okay, so I could write that as 2y squared, or you can leave it like that. That's fine. This one is going to be, we're adding 1 to negative 2. So that gives us negative 1, and then we divide by negative 1. Okay, here we're adding 1 to 1/2. So that gives us a positive 1/2, and we divide by a positive 1/2. Okay, this will actually simplify. So I've got negative 3 over x. And then whenever I divide by a fraction, so anything divided by 1/2 is the same as multiplying by 2, and then the half power is just the square root. So if I wanted to write that with everything simplified, that would be what it would look like. Okay, on this one, I have the square root of x, which is a 1/2 power, and then I have a 2 here. So this is actually going to be x to the negative 3/2 plus x to the negative 2. So if I take that integral, then I'm going to add 1 to negative 3/2. So that's going to be negative 1/2. And then I divide by negative 1/2, which is the same as multiplying by negative 2. Okay. Add 1 to this, we get negative 1, divide by negative 1, and we get negative x to the negative 1 plus c. Okay, now we're down to some trig ones. All right, so the integral of cosine is going to be the sine, stays positive. And then the integral of sine is going to be negative cosine, so this is going to be plus 3 cosine of theta plus c. Okay, and then over here, I hope you noticed cosine over sine is cotangent. 1 over sine is cosecant. So the integral of cotangent cosecant is just the negative cosecant of x plus c. Notice I got my plus c on all of those. All right, let's go forward and figure out what to do with this plus c. Sometimes we get an initial condition, which makes it possible to solve for c. Okay, so if I've got f prime of x, so I know what the derivative is, and I want to find the function, and I take the integral, right, to get the function. So now I'm taking the integral of x to the negative 3. Okay, so add 1 to the power, and you get negative 2. Divide by negative 2, and plus c. So this is our integral with terms of c. So this is like a family of functions. So I don't know what the exact y-intercept is. I just know it will be a function similar to 1 over x squared, but I don't know exactly where it is. Now, it did give me a starting point where x is 1 and y is 3/2. So I'm going to plug in 3/2, and I'm going to plug a 1 in here, okay? So 1 to the negative 2 is just 1, divided by negative 2 is negative 1/2 plus c. So I add the half over, and you get c equals 4/2, which is 2. So my actual equation all the way through is going to be negative 1/2 x squared plus 2. And I found that exact function, not a family of functions, just an exact function, okay? So really, when we're really going to start applying this plus c and finding the c value is when we get into these position, velocity, and acceleration graphs, okay? So remember, I go from position, I take the derivative, I get velocity, I take the derivative, I get acceleration. So now we're going to go backwards. Acceleration, the integral is velocity. Don't forget the initial velocity as your plus c, and then same with position. So this gives us acceleration, and we're going to find velocity, but it does tell me that my initial velocity is 1/6. And then it tells us our position. I guess it's not initial, but it does give you a point on the velocity equation. And then a position point is 2,5. So we're going to use these as initial conditions as we go down these problems, okay? So the velocity equation, we're trying to find the integral of acceleration to get velocity. So I'm taking the integral of 4t minus 3. So 4t squared over 2 minus 3t plus c. Okay, plug in the 1 and the 6. So 6 equals, plug in a 1 here, and we just get 4 divided by 2. So 2 minus 3 plus c. This is -1, add the 1 over, and we get c equals 7. So my velocity equation is 2t squared minus 3t plus 7. Okay, so we found the velocity equation. Now I can do the position equation by going one more integral. So 2t squared is going to be 2t cubed over 3. This one is going to be minus 3t squared over 2. And this is going to be plus 7t. Don't forget your constant of integration. Plug in the initial point 2,5. So 5 equals 2/3 times 2 cubed minus 2 squared over 2 plus 7 times 2 plus c. Okay, so I'm just going to use my calculator because it didn't say I couldn't. Okay, and I'm going to do, I don't see that very well. I'm going to store 2 in my equation, so 2 store x, and then I'm just going to type in what I had here. So 2/3 x to the third minus 3/2 x squared plus 7x. Okay, so I'm just storing 2 in there, and that gives me 5 equals 13.333 plus c, and then I'm going to subtract the 13 from 5. Make sure I'm not rounding, okay? And I get negative 8.333, and I can turn that into a fraction and get negative 25 over 3. So c equals negative 25 over 3. So if I go a step further and write our equation, I'm kind of out of room here, then that's going to be 2/3 t cubed minus 3/2 t squared plus 7t minus 25 over 3. So once I have these equations, then it can ask me other problems. Where's the max and min? How long is it in the air? What's the velocity at this speed? When is velocity increasing? Okay, so we can go through some different scenarios once we know what the equations are. Now this next example, if you have taken physics or you're in physics, you're going to love this. You're not even going to believe this. Okay, so get ready for some excitement, you guys. So we know that acceleration of an object that's falling due to gravity is negative 32 feet per second squared. Okay, so negative 32 is acceleration. If I take the velocity equation, I'm doing the integral of acceleration. So negative 32t plus c, right? So c represents, in my velocity equation, my initial velocity. We call that v0. So instead of c, we write negative 32t plus v0, and that just means my initial velocity. Okay, are you seeing where this is going? Okay, so now I'm going to take the integral of velocity to get position. So the integral of velocity is going to be negative 32 t squared over 2. And then I don't know what this number is, but I do know that the integral of that number is going to be whatever it is times t. And then I'm going to have my c again for my position. But initial position represents your s0, okay? So negative 32 divided by 2 is negative 16 t squared plus v0 t plus s0, which represents our initial position. Does that look familiar? Yeah, that is your equation when we talk about motion affected by the Earth's gravity. So we can use velocity, negative 32t plus v0, or position, negative 16t squared plus v0 t plus s0. So you need to go to your physics teacher and tell them that you learned where those gravity and acceleration equations came from and that you're really excited. Okay, you guys, let me know what questions you have. Bye.